All right, guys, today we got solving systems of equations by graphing. These are all linear systems. So I'm going to graph two lines and see what happens. Here we go. All right, a couple warm-up things here that you got to be able to do. The first one says evaluate that expression for x is 2 and y is -4, and it's going to be important a little bit later. So all you do is plug the 2 in for the x, plug the -4 for the y. 5 times 2 is 10, 2 times -4 is -8. Add those together, you get 2. Now that's a pretty simple skill, but you're going to need that today. The other skill you're really going to need is putting an equation in slope-intercept form. So if they give you an equation, this is called standard form of an of a linear equation. To get slope-intercept form, you're basically solving for y. So what I'm going to do here first is move the 3x over. That gives me 3x plus 12 or 12 plus 3x. Going to divide by 4. Now when you divide by 4, you got two options. Well, let's just do this. Let's divide each term by 4. Make that 3/4 x. 12 divided by 4 is 3. There's your slope-intercept form. Those skills you should already be able to do, but just giving you a warning, you're going to have to do both of those today as we go. All right, here's the basic thing about today. We're going to graph two equations, linear equations, so we're going to get lines, those linear functions we've been doing. So there's one equation of this line. Here's an equation of the second line. Now, you may not know this, but every single point on this line, that first line I drew, every single point, no matter which one I pick, actually solves that equation. There is an infinite amount of solutions to that equation, and they're all represented on a line, which is also infinite. Every point on this equation, that's what I'm drawing on right now, is a solution to that equation. Okay, so what's true about the big intersection point right smack there? It solves both equations. And that's what we're looking for. We want to find the intersection point because that one point, one set of coordinates solves both of those equations. All right, so here's our strategy. Number one, we're going to graph both equations by putting them in the slope-intercept form first. Number two, we're going to estimate on our graph what the solution looks like it is. Then number three, we're going to check it by plugging the point in and seeing if it worked. Okay, let's try one and see what we got here. You need to have them in slope-intercept form first. The good news is the first equation is already in slope-intercept form. So let's go ahead and graph it. The y-intercept is 2. Slope is -1, so I'm going to rise down 1, run 1. I didn't do a very good job. Let me try that one more time. You need to be as exact as you possibly can. A ruler would be nice. I'm not going to be able to give you one, but just make it as freehanded as close as you can to the real deal. That's not great right there. Okay, that one, I'm going to do that in red so you can keep them separate. I need to put that in slope-intercept form, so I'm going to switch places. The quickest way is to switch places with that y and that 7. Move the 7 over, move the y over, and it's done. My y-intercept is -7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Sorry about that. 7. Slope is 2, rise 2, run 1. And I'm going to connect those dots. La, la, la. Just like that. Okay, now what I'm looking for, obviously, is the intersection point. Because I freehanded, it's not perfect right there. The intersection point's right there. It looks to me like it could be at 3, -1. So what I'm going to do to double check that is I'm going to plug that 3, -1 into both equations and make sure that it works. So if I plug it in the top one, it would look like -1 for y and -3 for x. That would give me -1 is, sorry, that's a +3. Okay, so that would give me -3 plus 2. I don't know why I put -3 in there because it clearly says +3. And that's true. -1 equals -1. That's perfect. And you also need to plug it in this one. Double check it works there. So I'm going to put the 3 in for the x, actual 3, not -3 this time. -1, the left-hand side definitely equals -1. That's -1. It checks out both, so that's my solution, okay, to that system right there. So put them in slope-intercept form, graph as close as you can, and see where they intersect. Okay, there's two special cases. I'm going to show you one of them, and we'll do one in class tomorrow. I'm going to go ahead and graph this top one. It says it's already in slope-intercept form. Y equals 4x plus 3, so I'm going to go up to 3, rise 4, run 1. Got it. Connect those dots. La, la, la. There we go. Second one, if I'm going to put it in slope-intercept form, I'm going to, first of all, let's see. I'm going to move, well, let's do it a minute ago. I'm going to switch places with those two. So I'm going to take the 15 over here, and I'm going to take the 5y to the other side. Divide everything by 5. That becomes 4. That's the hint. That becomes 3. That's a big deal, that 4x, because look what I had in the first equation, 4x, which means the slope's going to be the same. So you know what? It's the exact same equation. So if I were to graph this one, even though it didn't look like it at the beginning, I'm going to get the exact same equation. So here's my question to you. those two lines lay on top of each other. Okay, so because they share every single point in common. So what does that mean? That means they have infinite solutions. It's not all real numbers because they're ordered pairs. Okay, but they have infinite solutions. The other case, weird case, is what happens if they have the same slope but they're not the same line? What if they're parallel? If they're parallel, they'd obviously have no solutions because they would never intersect. All right, so hope that makes some sense. I don't know what else to say about that. That's pretty good. So I'll see you tomorrow. We'll work on it. See you then.